Hello again. For this video we're going to show you how to decide when to use the vertex calculations versus the quadratic formula, and of course everything's based off of a standard form quadratic. The simple answer is anytime you want to find a min or max value, you want to use the vertex calculations. You have two options: calculate the line of symmetry, which is the x value, take this number here, whatever it is, substitute it here and here, and then output the y value. Or you can use the C, B, and A values in this formula and calculate the y value directly. In a parabola, your y value is your min or max value depending on your leading coefficient. So if your leading coefficient is positive, your u shape goes this way, creating a minimum. If your leading coefficient is negative, your u goes this way, creating a maximum. And the min or max are always output values, which describes a y value. If you're trying to find any other point on the graph where it crosses a horizontal line, which is a root, you're going to use the quadratic formula. So let's use the following example here. Say that water from a fire hose follows this path right here defined by this function, and you see it's negative, so we do know that our curve is going to go upside down like this. And we have two questions off of that. What is the highest the water can reach? And how far from the building must a firefighter stand to reach a window that's 49 feet up? Well, the easiest way to do this is to sketch a little graph. So here we've got a little L shape, because most of the time we only care about quadrant 1. So let's say that this right here is the 4 feet. 4 feet that this equation starts at. That's the y-intercept. And it's going to go up and then come back down to the ground. So this is x, this is y, this is horizontal feet across the ground, this is vertical feet, and that's what our x and y are going to stand for. So this graph is going to go up, and then it's going to come back down to the ground. So if you look at our first question, what is the highest the water can reach? Well, the highest the water can reach is up here, and that's at the vertex. So what we want to do is use the vertex calculations. And I'm actually going to use this formula right here, because I can identify my A, B, and C values. So the first thing you should do is identify your A, B, and C values. So based on this formula, this equation, A equals negative 0.006, B equals 1.2, and C is going to equal 4. A, B, and C values. So I want to know the maximum height, which is the y-coordinate. So I'm just going to use that equation, or that little calculation right there. And that calculation says to take C, which is 4, and subtract from it B squared, which is 1.2 squared, and divide that by 4 times A. So 4 times, and the A is negative 0.006. So if I simplify this a little bit, I get 4 minus b squared is going to give me 1.44. This calculation on the bottom is going to give me a negative 0.024. And I'm going to simplify it again, bring that down to the next line. So this calculation, this division, will end up giving me a negative 60. So 1.44 divided by negative 0.042, negative 60. And then 4 minus negative 60 is going to give me 64. So the maximum height here is 64 feet. That is the distance going up. So distance going up this way is going to be 64 feet. If I wanted to know how far away the water would reach, down here where it crosses the x-axis, that's an X intercept. That's also called a root or zero of the function. I would use the quadratic formula for that one. We're going to modify it just a little bit, because over here on the second question it says, how far from the building must a firefighter stand to reach a window that is 49 feet up? So I'm going to draw a little sketch of what that would kind of look like. So we know that this is 64 feet here. Let's suppose this is 49. Let's say this right here is 49 feet. This is not drawn to scale. Let's say that's 49 feet. And if I draw that all the way through, straight across, then I imagine, okay, here's the building. The water will go through 49 feet into, let's say, this window right here. once from that distance, so the firefighter's standing here, or a second time on the way down over here. So we actually have two distances horizontally across. So basically I'm taking this line and moving it up here and trying to find out where does the curve cross this horizontal line, which is a root question. So anytime you have a root question, you use the quadratic formula. Now this formula needs to be altered, or this equation needs to be altered a little bit, because the equation assumes that there is a 0 right here in this place. However, this is a height of interest, and the height of interest in this problem is 49. So we're actually going to put 49 here. But in order to make the calculation work, we need to make a 0 on this side. So we're going to subtract 49 from this side. So over here we get 4 minus 49. So the new C value ends up being negative 45. The A and the B values don't change, but the new C is negative 45. So I want to make sure I write that down. I still have the A and the B up here, but the new C value for my calculation will be negative 45. Now all I got to do is substitute these values, A, B, and C, into the quadratic formula to calculate my two solutions. We do know there's going to be two, because it actually would go through the window here at that distance and again at that distance. So let's go ahead and do the formula. Okay, so the formula says it's right up here, opposite of B. That's going to be negative 1.2 plus or minus. I like to go and do the denominator next. That's going to be 2 times A. A is that number there, so 2 times that's going to give me a negative 0.012, so 2 times A. Now the discriminant, which is the B squared minus 4AC, I like to do that a little someplace else, so I have 1.2 squared minus 4 times A negative 0.006 times C, which is, our new C value is negative 45 now, negative 45. Remember, this whole thing's going to be the radical. Simplify this a little bit. This first part right here gives me 1.44. This calculation in the back will give me a negative 1.08. That's under the radical. Subtract those and we get 0.36. And the last thing to do is take the square root of that. 0.36 square root of that is going to give us 0.6. So I'll come and put the 0.6 right here. So now we have two calculations for X intercepts, because we are calculating the X value from the graph, which is going to be this distance here and this distance here, the two different distances the firefighter can stand from the building. So one of those calculations is going to be 1.2 plus 0.6, and that's going to give us a negative 0.6, and we're going to divide that by negative 0.012, negative 0.012. So one of the solutions will give us, when we divide this out, it will give us 50, that's 50 feet. That calculation was done by negative 1.2 plus 0.6, and then divided by this. Now we're going to do it again, but we're going to do negative 1.2 minus 0.6, and that's going to give us negative 1.8. And we're still going to divide by the same, negative 0.012. And then when we divide that out, we get 150 feet. So this distance right here would be 50 feet, and the distance right here would be 150 feet. So the firefighter could stand either 50 feet away from the building or 150 feet away from the building and still get the water into the window that's 49 feet above. Now, which one is the correct answer depends on the scenario. Let's say we said, what's the furthest the firefighter could stand? Well, the furthest would be the bigger of the two distances. If for some reason we didn't know how wide something is across here, we would just subtract those two, which would be 100. But since we didn't specify which one we were looking for, either answer is actually acceptable. You can stand 50 feet away, and you would go through the window on the way up, or you can stand 150 feet away and go through the window while the water's on its way down.